Welcome to everyone joining in. Um, we'll get started here. I can see people are still trickling in, but welcome to today's webinar. It's going to be integrating long-lasting insecticide netting into IPM programs after harvest. My name is Laura Isles. I'm one of the co-directors of the North Central IPM Center. We're one of 4 regional IPM centers supported by USDA NIFA Crop Protection Pest Management Regional Coordination Program. We're on a mission to coordinate IPM across the region by sharing and promoting IPM research, extension, and teaching activities. As you're listening to today's webinar, please type any questions that you might have in the Q&A part at the bottom of your Zoom, and our speaker will answer all questions at the end of the webinar. So without further ado, I will pass it to Rob Morrison from USDA ARS Center for Grain and Animal Health Research to talk to us about integrating long-lasting insecticide research into IPM. So take it away, Rob.
All right, thanks, Laura. I'm excited to be here today. I'm going to be talking about a project that has been a collaborative one here at USDA ARS, also Kansas State University and Arkansas State University on trying to integrate long-lasting insecticide netting into IPM programs. And so before I jump too much into it, I just want to give a little bit of background for all of us. Stored product losses, so losses to those durable commodities after harvest are substantial, so they can range from 2 to 30%. As these commodities move from storage to processing, marketing, and then end up in people's homes. And worldwide, these losses are estimated to exceed $100 billion annually. And this is due to, in large part, to a variety of insects that attack these commodities. So there's been 1,600 species associated with these stored commodities, and 70 of these are economically significant. Now, historically, these stored product insects have been managed with a combination of methyl bromide and phosphine. Both of those are fumigants. Methyl bromide has been phased out for the most part because it's an ozone depleting compound that was banned by the Montreal Protocol. But in its place, tablet or containerized phosphine remains the most common. Now, there's some increasing challenges to fumigation with phosphine. On the consumer side of things, there's an increasing demand for organic or low insecticide inputs throughout the supply chain. And many other fumigants that used to be on the market in the US are no longer used or available. In addition, there's been a dramatic rise in phosphine resistance by the major stored product insects around the world, including here on the Great Plains. And another sort of challenge that food facilities have to face are the movement of these insects around, and they can be moved one of 2 ways. The first is through human-mediated dispersal. So you can imagine a commodity arriving to a food facility, perhaps it's already infested, that commodity gets moved around, so that would be sort of human-mediated dispersal. But we can also get landscape movement of these insects into food facilities. So these facilities are giving off lots of attractive food odors, and our stored product insects have refugia in the landscape that they may be on, and then they can immigrate into these food facilities. Now, one way to potentially intercept those immigrating insects is to use long-lasting insecticide netting. And this could also potentially support managing phosphine resistance at these food facilities by layering on another mode of action. Historically, these insecticide nets have been used as bed nets to reduce the spread of malaria in Africa and other tropical regions. And the real benefit of these nets is that it confines insecticide use to the net and away from the commodity. And so we could maybe use these to cover vents, eaves, or openings, or perhaps to partition different parts of a facility internally. My colleagues here in the unit have shown multi-year efficacy, and they've been very promising in a variety of studies after harvest at our lab, and others in Greece have pursued. Now, the two nets that we focused on are 0.4% deltamethrin net. This is produced by Vestigard, and it's in the process of being re-registered in the US. We also have a 0.34% alpha cypermethrin net. This is labeled as Carafend and produced by BASF. So you can see on the left, we have our Vestigard net. On the right, we have our BASF net. And in most of the experiments that we have conducted, we're comparing it to a control net, which looks identical but lacks the insecticide part of the insecticide net. Now, there have been some recent advances by our project, which include showing that the netting is not repellent either at a distance or with contact. We found that brief exposures can result in multiple-fold decreases in movement that are immediate and long-lasting. We've also found that contact can prevent dispersal to commodities in a warehouse setting. And so here's just a little video to give you an example of how much this affects behavior. On the right, we have our controls, happy-go-lucky moving around. On the left are insecticide-exposed individuals. They're pretty much completely stationary. So this really can significantly affect their behavior and movement. We've also found that exposure to insecticide netting eventually results in 70% or more mortality for over 10 of our stored product insect species. And we've also found that multiple brief exposures to the net has the same effect as a single larger exposure. And this might be important because, you know, we can imagine the insect kind of climbing onto the net, maybe getting dosed, falling off. Maybe it recovers, climbs back up onto the net. And so those multiple brief exposures can have the same effect as a longer one. But there have been some concern voiced by stakeholders, which is, you know, whether the insecticide netting is compatible with common IPM tactics at food facilities. And so this has included fumigation and bulk storage, as well as residual insecticide usage in warehouses. And also, can insecticide netting help us overcome phosphine-resistant populations? And so this is what I'm going to focus on in the talk today. Specifically, can we use insecticide netting to overcome phosphine resistance? Can we use insecticide netting to reduce damage in fumigation and bulk storage? And can we use insecticide netting to enhance the efficacy of residual contact insecticides in warehouses? So I'll begin by talking a little bit about phosphine resistance. Just as a primer, phosphine resistance is a problem worldwide, but also here in the United States, especially in the Great Plains. So in Kansas, we have 50 to 93% of our lesser grain borer populations resistant to phosphine. So that's one of the key pests in bulk storage. In Riley County alone, which is where my center is located, we have 48 to 77% of lesser grain borer populations resistant. So this is a problem. And so we were looking here at different active ingredients and their efficacy. So we looked at dinotefuran, permethrin, and doxycarb. Also the deltamethrin net that I mentioned, and comparing that to a control. And so we exposed red flower beetle and lesser grain borer for periods of 0.5, 2, or 60 minutes, and then recorded a movement either immediately after exposure or 24 or 168 hours later, and tracked that movement for an hour. And so this is kind of how it worked. We exposed our insects on the material, placed individuals separately into Petri dishes, and then tracked their movement with a network camera that sent all that data to software running EthoVision. And then we could look at the distance moved, velocity, some of those key movement indicators. And so here's kind of the take-home graph from this. You know, in answering whether it can support phosphine resistance management, we have the mean distance that, in this case, lesser grain borer is moving, and we have our control netting. I'm just parsing out the deltamethrin netting here. We have our control netting on the left, and our insecticide netting on our right. And we have two different strains that we use, either phosphine resistant strain in black, phosphine susceptible strain in blue. And you can see that basically both strains were affected equally, suggesting that this net can help with phosphine management. And when we look at all those other variables that I mentioned, so by exposure time, so 0.5, 2, or 60 minutes, again, it didn't matter. Our strains were affected equally. And the same was true with time after exposure. So again, equal effects for both strains. So just to summarize there, we found that insecticide netting is effective both for phosphine susceptible and resistant populations of lesser grain borer. I didn't show the data, but it was similar data for the red flower beetle. And we also found in this study, though I didn't show it, that multiple active ingredients were effective, including dinotefuran and doxycarb and permethrin. So overall, this might be able to play a role for management of phosphine resistance at food facilities. Next, we wanted to look to see if the netting could be effective in reducing fumigation and damage in bulk storage. So for this, we had a grain bin study where we had these buckets, which we called miniature silos. And we drilled holes at the bottom of these, and either the holes were left as is. We put a net without insecticides, so that's our positive control around the holes, or we put BASF netting around the holes. That's our insecticide net. We put 500 grams of wheat into each of these and had 20 for each treatment, which we placed in one of three silos. And then we took monthly samples of 100 grams of grain to check for dispersal and insect damage. We then, after sieving out the adults, held that grain for 6 weeks to determine progeny production. Now, half of these were assigned to a fumigation treatment, which was triggered based on a conservative FGIS specified tolerance of either 2 adults per 100 grams or 16 insect damage kernels per 100 grams. And just to make sure the population pressure was high, on a monthly basis, we released 100 red flower beetle, lesser grain borer, and rice weevil in these bins to augment the naturally occurring insects. So I'm going to show the data from this experiment from 2022. We have similar data for 2023, but it's the same results. So I'm just going to show you 2022 data. So for insect dispersal, we're looking at the total number of stored product insects that are in those 100 grams by our treatment. So negative control, positive control, or our insecticide netting treatment. And you can see we have a significant reduction in the number of insects dispersing when we look at our insecticide netting compared to our other treatments. So we had a 83 to 99% reduction in insects, and that was regardless of whether those buckets were fumigated or not. Now, if we look at progeny production, we see a similar sort of pattern where we almost have no progeny production in the insecticide netting, even compared to the buckets with the netting but no insecticide. So there we had an 89 to 99% reduction. We also found that damage was significantly reduced by 37 to 99% in bins protected by the insecticide netting compared to our other treatments. And then the key question, can we fumigate less? We're looking here at the number of times that the tolerance was reached or would have been reached to trigger that fumigation in each of our treatments. And it turns out that we can reduce fumigation by 58 to 100% when we use that insecticide netting compared to our other treatments. So to summarize here, we found reduced damage and dispersal by stored product insects in bulk storage. So ultimately, insecticide netting can reduce the need for fumigation significantly. And really, this was a very promising look at using insecticide netting in bulk storage. All right, the final little vignette I want to talk about today is about whether insecticide netting can enhance the efficacy of residual contact insecticides in warehouses. Now for this, we had a residual assay where we had sort of a metal frame that we had removable concrete squares in. In the first square, we were releasing our insects, and we did this for both lesser grain borer and red flower beetle. And then they were able to disperse across two of those squares that either had our insecticide netting where that was present, or a sprayed residual insecticide in zone T2 there. And then we had either a food zone that consisted of whole wheat or flour at the end to prompt them to move. So our treatments included untreated controls, insecticide netting only, or residual spray only with either Sentinel, so that was 4.75% deltamethrin, or evergreen alone, that was 5% pyrethrins, so that's organic. And then we had treatments with both a strip of the insecticide netting and the residual spray, either the Sentinel or the evergreen. So in each assay, we released 30 insects, gave them 48 hours to disperse, and then checked for which zone they dispersed to, as well as their conditions, and had a total of 6 replicates for each one of these. So this is, these are the insects dispersing to that food zone at the end of the assay. So we have the percent of lesser grain borer, and you can see here's our control on the left. So lots getting across there, but this significantly decreases when we have one of our 3 insecticide treatments. So evergreen alone, centennial alone, or insecticide netting alone. But we can decrease the amount dispersing even further when we include both that insecticide netting and the residual spray. So we get increase in efficacy there of between 10 to 20%. Now, if we look at insect reproduction, so progeny production, we see that again, compared to our positive control, but also the evergreen only, we can decrease progeny production by using the Sentinel only, insecticide only, as well as one of the 2 combination treatments. Now, if we look at insect survival, this is for those at the release zone. We see sort of decreasing survival. That's the alive or in blue there with our insecticide treatments. And we have an even further decrease in survival when we combine that insecticide netting with the Centennial specifically. And then in the food zone, this is what the survival looked like. So we basically had no individuals making it to the food zone for our combined insecticide netting and Centennial treatment. So that was kind of the key message here. So just to summarize, insecticide netting ended up reducing dispersal by stored product insects in warehouses. The combined use of insecticide netting and a residual insecticide increased overall mortality by 10 to 20%. So again, combining this tactic with residual insecticides, which are already practiced at food facilities, is very promising. And finally, I just want to give the project in numbers here, because this team has been an amazing team to work with, and they've done a lot. So we've ended up getting 60 peer-reviewed publications with a total of 851 citations, H-index of 17. We have 34 other publications, including fact sheets, which I think the link will be sent on the chat for that, but also some reports and proceedings. We've had a total of 889 talks, 68 significant invitations in 19 US states and 12 countries. Our team has organized 23 symposia, and the students that have been mentored on this project have placed first or second 47 times at annual meetings and regional competitions. Total of 49 staff trained, 110 meritorious awards to our team members. And we've had over 60 outreach events with about 17,000 in-person contacts. So just some take-home messages. Insecticide netting is compatible with existing IPM tactics at food facilities. And some of the concerns that were voiced by stakeholders should not be a major issue. With that, I'd like to thank my whole lab, but especially Sabita Ranavat, who is a PhD student on this grant, and Rachel Wilkins, who is a master's student. So with that, we can open it up for questions. Here's the QR code for CEC continuing education credits for those who are interested in getting those. And I'm happy to be here. Thanks.
Thank you so much, Rob. So again, any questions can be placed in that Q&A box there at the bottom of your screen. And we did have a question come in from Betsy Danielson. Has the netting been adopted for commercial use in bulk storage yet?
Yeah, so well, not bulk storage per se, but the alpha cypermethrin netting, which is produced by BASF, has been adopted pretty widespread in tobacco processing facilities in Europe. And there they sort of use it in a pallet deployment over the commodities. And all the data suggests that it's very effective for that. So, but to my knowledge, it hasn't yet been adopted for bulk storage.
Are there cases where it's been implemented yet in real world conditions?
Yeah, so what I just mentioned, the tobacco storage and processing at facilities in Europe, especially in Southern Europe, is pretty common. The Carafint is registered for post-harvest food facilities and some of our main stored product insects after harvest in the US. And Vestergaard is in the process of re-registering their net. Then the registration had lapsed, but they should be able to get that re-registration by October of this year.
Okay, does the netting need to be like, what's the lifespan? Does it need to be retreated every few years or replaced?
Some of my colleagues here have looked at the residual efficacy on a monthly basis over 2 years and had the netting deployed in a couple of different environments, including the south-facing side of outside of a building that was exposed to precipitation and sun, whatever. And at that location found the netting was good for about 1.5 years.
Okay. Do you have concerns about resistance developing if you are just using the insecticide netting with a class of insecticides?
Yeah, so that's a good question. Obviously, I would never recommend only using the insecticide netting. Like this should be used in the context of a holistic IPM program, where you may have some other residual insecticides or fumigation or whatever that needs to happen for the food facility. And so in that context, there'll be multiple modes of action that are being used at a particular food facility. And so I don't anticipate like a huge uptick in resistance. The other thing with that is we've also looked at using this pyrethroid insecticide netting with pyrethroid resistant insects. And we found that we can overcome that resistance when it's used when there's also a synergist exposure for our insects. So that was piperonal butoxide. And so we found that resistance could be overcome that way.
Again, if there's any other questions from the audience, please fill them in. I noticed you mentioned they're being used in Europe. Are there any registered for use here in the US yet?
Yeah, so the Carafin netting produced by BASF is already registered here for use in the US. And as I mentioned before, Vestergaard's seeking re-registration of their products, so that should hopefully be forthcoming.
you so much. I don't
you.
see any other questions coming in, so thank you so much, Dr. Morrison, for sharing this valuable research coming out of the USDA ARS Center for Grain and Animal Health Research. It's so important and really glad you shared it with us. There's a poll did pop up there, and it really helps us all for you to fill out this poll. So please do this before you leave the webinar. And just to let everyone, all of our audience know, our next Pest in Progress webinar, we are changing the time, so it will be Wednesday, July 16th, but at noon Central Time and 1 Eastern Time. So we're moving it forward by a half hour. So we love all of you who join us each month. So just make note, it will be a half hour earlier next month, where we will have Dr. Matt O'Neill from Iowa State University presenting on soybean aphids. Soybean aphids are resistant to pyrethroids. What now? So some more pyrethroid resistant insects. So keeping in a theme. So thank you again so much, Rob, and thank you all for joining us, and we will see you all next time.
Thank you.